Great. All right, thanks. Hello, everyone, and welcome to the July 2025 Link Tech Talks. My name is Colin Orion Chandler, and our co-host is Mi Dai. We are both LINCC Frameworks Project Scientists. I'm at the Drexel Institute in the University of Washington, and Mi is at the University of Pittsburgh. Link Tech Talks include presentations and demonstrations that showcase work done by the broader Rubin software and archives community with the goal of further enabling LSST science. And unlike traditional talks you might hear at a conference, Tech Talks highlight the technical aspects of the work being done. So we hope these talks will provide a useful forum for a range of groups and authors to present and to learn about and discuss efforts of interest in the analyses of LSST data. The Link Tech Talks are delivered virtually every second Thursday of the month at 10 a.m. Pacific. We do not have one next month, but we will have one in September. And so today's topic is citizen science in the era of Rubin Observatory. So today we are joined by Clare Higgs and Rosas of the NSF-DOE Vera C Rubin Observatory Education and Public Outreach Team. We're also joined by myself on behalf of Rubin Comet Catchers, the Citizen Science Project. And we'll be discussing, citizen science in the era of LSST. I think I'm going to let Claire introduce herself and Eric. I'm going to just say for myself that I'm the PI of the Rubin Comet Catchers and also the Active Asteroid Citizen Science Project, the co-chair of the LSST Solar System Science Collaboration, and a member of the Rubin commissioning team. So for the talk, please ask questions in Zoom or the hashtag LinkTechTalks channel on Zoom. You can type any questions in the chat or raise your hand. And as a friendly reminder, they are being recorded and will be posted on YouTube later. So I think with that, Claire and Eric, please take it away.
Okay, great. I'll just share my screen here and hopefully someone give me a thumbs up that that's shared okay. Awesome.
Great. Okay,
perfect. So my name is Clare Higgs. I am the astronomer on Rubin's education and public outreach team. And I'm going to talk about citizen science today. Eric Rosas is also here and will chime in with some technical details in this talk. Eric is the tech lead on our EPO team. So citizen science with Rubin is reaching a very exciting moment because, as Colin will talk about later, we have our first citizen science project. Citizen science in Rubin has been something that has been in mind for a long time, and we're kind of excited to reach the stage where things are becoming reality and projects are becoming available. I'm going to start off just by kind of giving a lay of the land, the kind of framework of what we're doing, why we're doing it, and kind of what the kind of motivations are and what resources we've provided. And Eric's going to add some kind of more details about what we're supporting and providing. The Rubin CitSci team is a collaboration of folks from the education and public outreach team like myself and Eric, members of the community science team, the CST team, as well as we work closely with the Zooniverse. I'm sure the Zooniverse needs no introduction, but just in case, this is a well-established citizen science platform that has many astronomy projects, but also covers a full range of topics from biology to handwriting to weather data and all sorts. And so this is a great online platform with resources for running projects and also for volunteers. And of course, we work in collaboration with our Rubin community in many ways as well. As a brief overview, what we are trying to do is create tools and a community for Rubin Observatory citizen science. We're ready to help make projects happen. So one thing just to make really clear off the top is our CitSci team is not directly running projects. We are helping members of our science community, like Colin, run projects and hopefully making this easier. So our motivations for doing this are supporting our scientists, trying to reduce the effort required to start and maintain and run a project and help where we can. And also as part of the EPO mission, trying to reach a broad audience. And I'll touch on this a little bit more on the next slide. But really this all kind of centers around the data volume problem of Rubin. This is, of course, a lovely problem to have, that Rubin produces a huge amount of data. And so for our project leads, trying to help support ways to manage and use this data for citizen science is something that we try and provide. And also for the public, maintaining interest, this is not a sprint. We have a very long marathon, or I like to think of it more of an ultra marathon of science coming. And so maintaining the public interest and momentum is really important to us. So just expanding on this thought slightly, um, as a whole, our education and public outreach team, we try and create ways for the public to appreciate and enjoy Rubin data. Um, Rubin data is inherently inaccessible to the public, and so we create lots of avenues and ways for people to participate. Citizen science is amazing because it's an opportunity for the public to be part of the scientific discovery process, which is awesome and such a win-win for both our science community and for the public. But as we know, it's a large volume of data, a decade-long survey, and more than a decade of science. And so respecting the public's engagement, time, and effort is really important, and expanding that community as much as we can really matters. And so these are some of the themes on kind of what we are building here. So how is Rubin supporting CitSci? Hopefully that little bit of an introduction gives an idea of, why we'd want to do this, but how are we doing this? And so really, we are working in partnership with the Zooniverse, as I mentioned, to try and create ways to use the amazing data and the resources developed by Rubin and all those resources that are available to our science community to connect to the Zooniverse, and so we can kind of leverage both of these avenues of analysis together. And so our goal here is to facilitate making project development more straightforward for project leads, and also to foster this community of volunteers who are ready to tackle the data that we present. So taking this first goal of how making projects a little bit easier to start with Rubin data and breaking it down, there's a suite of resources and support that we've kind of started to nurture, and we're really excited to develop further. I will say that citizen science and with Rubin has been in mind for a very long time, but we are really kind of approaching the moment where there are projects and there is data to work with. And so a lot of these things are kind of still in development, and we're really excited to develop them specifically for the needs of the community as the community now has projects to embark on. So some of the resources we have are templates for projects, some documentation and support from our team. And really the backbone of what we're providing is a pipeline to programmatically send and retrieve data between the Rubin Science Platform, the RSP, and Zooniverse projects. The RSP is not designed to do massive downloads and uploads, and the data volume is a little bit complex, and so we have developed this pipeline that also provides data storage for your objects that you're classifying, and these are presented in a series of tutorial notebooks which demonstrate how to use these notebooks or how to use this pipeline in a variety of ways, and of course should be kind of launching points for projects of different types. So taking a closer look, the documentation lives at citizen-science at lsst.io. There is more documentation coming soon, but there is some there as well. A couple aspects I want to emphasize that are available now is we have a data policy. So citizen science projects have to exist within, of course, the larger data rights and data policy of Rubin. There's no exception for citizen science. But understanding how to show this data to the public, to get the volunteer effort to support this classification while under that framework is a little bit confusing. So we have a data policy there that hopefully breaks down how you can make these projects happen. We have an existing project catalog, which is just under development, but will show projects that have started or have finished, or projects that are about to start, with the intention of making it easy for scientists in the community to be aware of the landscape of projects that are there, and so avoid project overlap and make sure projects are nice and distinct, and also foster collaboration where necessary. And also from our community science team, they have provided some advice for machine learning integrations as well for projects, and how machine learning on the RSP side can work well with citizen science projects. So touching on the software, mostly the software exists in a citizen science or a software package. This works on the cloud instance of the RSP and allows you to programmatically send the data back and forth and with the data storage. And Eric will give some more details here. And these tutorials are linked on the documentation pages. The tutorials have a couple different flavors. We have a basic notebook, which talks about sending cutouts to the Zooniverse, and it's kind of exists in our basic notebook. We also have a flipbook example, which I think Colin will show an example with in his project. And we also have some examples of classification aggregation. So once everything is classified on Zooniverse, showing two different ways of aggregating the data. One is a simple aggregation done on the RSP, and one is using some of the aggregation on the fly techniques that are on Zooniverse. So you can aggregate it and retrieve kind of aggregated data. I'm going to skip this, and I'm going to let Eric take it away for a little bit and talk a little bit more details about what's in the pipeline.
Yeah, thank you, Claire. Some of you may already know this terminology, but just the way my brain works, I always like to define things before I start tossing them at a crowd. So Zooniverse, kind of going off the assumption that majority of people in this call have heard of the Zooniverse, know about citizen science, as Claire's been explaining it. There's vernacular that is specific to Zooniverse, and I'll be referencing it in the next slides. So if you're not familiar with this is just kind of a breakdown of the vernacular that is used on the Zooniverse platform. So conceivably, there's a PI that wants to start a citizen science project, and there's some data that's already been curated or is about to be curated. And with Rubin, that means usually there's a lot of data, right? Like maybe tens of thousands of image cutouts, who knows? Now, when you are using the Rubin Citizen Science pipeline or just using the Zooniverse website, when you send data to Zooniverse or manually upload it for your Zooniverse project, Zooniverse refers to that data as a subject set. It's just a batch of data that's been uploaded, sent, and within that subject set, an individual datum, let's call it like a single image or a flipbook image, that's referred to as a subject. So a subject set contains many subjects. And the way that Zooniverse keeps track of which subjects are associated to which subject sets, which are associated to which workflows, which I'll get to in a sec, is through what they refer to as a manifest file. That's typically a CSV. It follows a very specific canonical format, canonical to the Zooniverse. And all those are associated to your workflow. So if you have a Zooniverse project, you could have one or many workflows. And the workflow is how you define the different classification rules, the different questions that the citizen scientist is going to be asked or are going to be asked. And simple use case, is this a galaxy or is this noise? That could be a simple question that could be added at the workflow level. And there could be many subject sets within a single workflow. At some point, through some retirement rules or when the PI decides that their workflow is at a good place and they can take that data and start using it in their research, they can request for the classifications, and the classifications are the answers that were provided by the citizen scientists, all those crowdsourced answers to the yes or no, this is a galaxy, this is, whatever. And there are a number of potential reasons why answers may differ. So if like 20% of citizen scientists say something is noise, but 80% say it's a galaxy, well, that gets aggregated. And through rules on the Zooniverse side, some reasonable degree of certainty can be made about what the actual degree of confidence is for the answer to that question for that subject or subject set. And that's known as aggregation. And so the final step in the Zooniverse project is to request that aggregation. And that's really the data that you get back from the Zooniverse. And that's all the goodness that that you want from a citizen science project. Oh, go ahead and click next, Claire. So admittedly, the text is the font's very small. If you go to citizen-science.lsst.io, you will see a larger version of this. And I encourage you to go there because I'll be really talking through some of these points here. Now, I think, this is really the point for Rubin to start showing the scientists that are using the data, what is this pipeline? Maybe you all have heard of it. Maybe you've all tried some of the notebooks, but what does it do? What does it not do? And why is it needed in the first place? Well, I think a lot of these different little process boxes can be summed up as there are manual steps that go into creating a Zooniverse project. The curating of the data in the Rubin Science platform, the creation of the manifest file, which you would need a single CSV line for every single image that you curate. And there's other metadata that's required by the Zooniverse. You would also need to somehow host that publicly. Conceivably, you could zip it up and download it and then upload it to the Zooniverse page manually. But then you're kind of at, if something happens to your local machine, you could lose that original data. So hosting is a question. How do you host whatever the data is for the Zooniverse platform? And how do you, as an individual, as a PI, keep track of where your project is at, how to send more data to a specific project, how to request classification, aggregation, and so forth. And we're really enumerating over a number of use cases. As Claire said, we have a couple in mind that we've already have those notebooks in a fairly stable place. So the way this, and I need to zoom in, I need to scoot forward myself. So there's an idea that you have data. Either you have it already or you have the data that you want in mind. And if you, for whatever reason, because as Claire mentioned, currently the pipeline only works at the data.lsst.cloud instance of the notebook environment. Now it's entirely possible it could work at the USDF notebook environment soon, but those conversations still need to happen. There are ongoing conversations about enabling it at the UK IDAC notebook environment. So for now, just framing it, and I'm framing it this way to address what the problem statement is that you might not have your data at data.lsst.cloud. You may have it at the USDF. In that case, you might just need to download it and then re-upload it to the cloud environment, the cloud RSP. So, or you may have the data in mind and you want to go through one of our tutorial notebooks or modify a tutorial notebook and get your data. And for the sake of this diagram, let's say it's 10,000 image cutouts. So you got all those in your RSP home directory, and now you want to initiate that sending of the data to the Zooniverse. Well, there's a bit of a assumption here, a bit of a caveat, is that you need an account at the Zooniverse, so that's not diagrammed here anyway. So you create your Zooniverse account, but you don't have to create a project yet. The notebook or any of the notebooks will actually help you create your project. If you have multiple projects on the Zooniverse, you can select which project you want to send the data to, and then through the help of the Rubin.CitSci PyPy package, which only works in the notebook environment for security reasons, it parses out all the data that you've curated. Let's say it's, again, the 10,000 image cutouts. It will automatically create the manifest file that Zooniverse expects in the format it expects. It will zip it all up and it will send it to Rubin EPO cloud storage. Now, there it will ultimately be hosted. But as far as what the notebook and the PyPy package do, its job is mostly done. There's a backend service, and that's this little blue column here in the middle of the diagram. And that backend service is in charge of unzipping that zipped file, making sure that there's only PNGs, JPEGs, maybe WebP soon. The file formats that have been approved as per the data policy, the Rubin data policy. It will then parse out the manifest file, make sure that it looks good, make sure that it's not going to contain something that's going to get rejected by the Zooniverse. And it will then, once that zip file has been unzipped and parsed, upload each individual image to a public storage bucket where it will ultimately be hosted for the Zooniverse. And you get all that for free. So this is, I guess you could call it, this is a gift to the science community. Rubin EPO, we're happy to host it. We're happy to take on hosting costs. There are a number of things that Rubin and specifically EPO would like to keep track of, as Claire mentioned. So as part of the EPO mission, we have a vested interest in engaging the public in a number of things, classroom investigations, showing off cool images, etc., but also engaging the public to sign up for the Zooniverse, say, or if they're already signed up for the Zooniverse, to hop onto these Rubin projects and help PIs classify their data. So the way that we do that, or the way that we keep track of it, is that we keep a database, and it has a number of tables. I wasn't prepared to present on that, but if that's of interest at some future tech talk, I'm happy to present on the data that we collect, because I know data is a concern these days. And what that database contains is who is the PI that initiated the transfer? What is the Zooniverse project that it was sent to? The data that was sent, we need to keep track of that for auditing purposes, but also we can use that to automatically detect, oh, well, there's a wide overlap, and this is the pie in the sky. This isn't perfect. We're still kind of working through the details of this. But Claire mentioned encouraging collaboration. So how do we automatically do that? How do we detect, oh, well, seems to be a large amount of data in this Zooniverse project, and you just try to send, or you just send this data, and it seems like there's a lot of overlap. So how can Claire, how can we detect those things proactively so we can either automatically or manually reach out to those PIs and say, hey, were you aware of this project? Maybe you should consider collaborating, or at the very least chat. So those are big reasons why we collect the data. Also, because for data rights policy, the number of cutouts that are sent is limited initially to 100, and that's just to prove out your project and get data rights approval. And after that, it's 10,000 individual images, individual flipbooks that you can send. You can request for that number to go higher, but the database and the backend service are how we assert those policies. Ultimately, the manifest file gets hosted as well, and at that point, the notebook gets notified that, hey, processing's done. We're going to let the Zooniverse know that the data is publicly hosted, and this manifest file is also available to the Zooniverse to ingest and to load that data into your new subject set. And Zooniverse does all that behind the scenes. So at some point, after running that notebook cell, and it's really a single notebook cell to send the data, the PI will get an email at whatever email address they registered with the Zooniverse and says, hey, you have a new subject set available. And we'll include a little link. You can click on it. You can go to it. You can see all the data that's been uploaded. Now, follow up to that, or before I get to that, let's say you iterate over that any number of times. You send some batch of data, you wait for it to be classified, you send another batch, wait for it to be classified, and that all is keeping track of which data went where, as I mentioned, to which project, which data has already been sent, is something that the notebooks and the PyPy package and the backend service help the PI keep organized. Now, one thing I forgot to mention about the public hosting is that should anybody using the citizen science pipeline somehow lose track of the original data they sent, I don't know, I can't really speak for the RSP notebook aspect, like how often they're going to be asking users to clean up their home directory, maybe never, maybe periodically, who knows. But should anybody lose track of the original data, we EPO can retrieve the original zip that was sent and just send it back to whoever's requesting it. Forgot to mention that earlier. But let's say, going back to the topic I was just mentioning, you're iterating a number of times, sending data to the Zooniverse, and ultimately you're like, okay, my workflow's done. I want to get that data, that classification that's aggregated. Well, there are notebook cells in our tutorial notebooks to request that classification aggregation. So you can then, and Claire's telling me I need to wrap up, so I'll hurry. So then you can run the notebook cells, and that's a bit of an asynchronous process, but you will get a notification saying, hey, Zooniverse has done what they need to do to aggregate those classifications, and now it's available to download at this link. So in summary, a large part of what the pipeline does is try to alleviate the pain points of running a Zooniverse project, of keeping everything organized, and the hosting problem, where are things hosted, etc. Go ahead and click next, Claire. I think that's pretty much it.
Nope. All right. Yeah, and so I think you summarized there nicely, kind of what's all in here, the storage being a big one, and also facilitating that. Yeah. Okay, so hopefully Eric has touched on some of the aspects of this pipeline that are there. I'll very briefly just touch on the second part of our goal of trying to help the community volunteers, and then hand it off to Colin to show exciting new project that's happening. So we really want to support this community of volunteers as they hopefully engage in many citizen science projects. And again, so respecting the time and effort and emphasizing the science that comes out. The motivation of volunteers is strongly shown to be wanting to contribute to scientific research. And so through EPO resources, we're excited to share how citizen science contributions have really made a difference in the scientific process. And connecting to the broader landscape of EPO projects. So one thing that we have got started now is a Rubin community page, which will show all projects using Rubin data. Currently, we have probably one project, but there is more coming soon. We have a couple other projects with DP1 that should be coming out in the coming weeks. And of course, there's room for many more. And of course, as the alert stream and DP2 and DR1 come out, we're excited to see many more projects ahead. And hopefully this promotes some collaboration or sharing of volunteers across projects, which will be important for the fact that projects have different cadences on how much fresh data there is, and so there'll always be something for people to participate in. And so we also connect to the rest of EPO's initiatives, and we can help support, promote, and broaden the reach of projects. So I will just wrap it up there and just say I'm always around for questions. And again, the documentation pages are there and are ever growing. So please do keep an eye on them as they expand. So I will stop there and hand it over to Colin. Oh, and Colin has disappeared. There we go.
I'm here. If you could just stop sharing, that'd be great.
Oh, there we go.
Thanks. Thank you so much.
Oh, sorry, my stop share.
Awesome. Okay, let me share my screen here. And can you see my screen okay? Awesome. Great. All right. Well, thanks very much for that, Claire and Eric. That definitely helps us understand the background and the scaffolding that's there, and I really appreciate it a lot. So to talk to you today about Rubin Comet Catchers. This is a citizen science project that is live. You can go to cometcatchers.net and it'll take you over to the Zooniverse page. There's a lot of people involved, and so let's just move on here. So I know it's supposed to be tech talk, but I have to give the science motivation because I'm a scientist. And so why are we doing what we're doing with this project? Why bother? So for us, a lot of the motivation has to do with volatiles in the solar system. We'd like to know answers to fundamental questions like where did the water on Earth come from? Because believe it or not, this is not really a completely solved question. This diagram here shows sort of early solar system and some different origins like comets and maybe accretion and asteroids delivering things after the fact. And these are all important for understanding conditions needed for life and space exploration. We also have different astrophysical processes at play that we're trying to understand. So we talked about sublimation before, especially true with comets and also main belt comets. These are asteroids in the main belt that have comet tails due to sublimation. There's also impact events, like famously the active asteroid we created by hitting it with a spacecraft from Earth, DART. And that also talks about the planetary defense implications, which are important as well for understanding comets. There are other methods of activity, like rotational disruption, where things spin so fast that they start to fly apart. Thermal fracture, we get a nice meteor stream from the gem-emitted meteor stream parent, Phaeton. Microglia impacts, you get a spacecraft to an asteroid and it turns out it's got little centimeter rocks flying everywhere. So there are many reasons that we understand this. These are not mutually exclusive. You can have something impact that exposes ices, which then sublimate. So it's a complex and very exciting area of study. One of the issues is they're very rare. So despite the fact that we've known these as the first solar system minor planets for as long as there have been people, there are only a few thousand known comets. Even adding in active asteroids with comet tails, etc. These all pale in comparison to the millions of known asteroids. And so we really want to find more of these objects in order to be able to understand them better. I do love that we have an image of the very first discovery of an active asteroid on the left. That's from a plate from the European Space Organization of Wilson Harrington. And then there's that impact again, talking about the DEIMOS there, the DART mission. Sorry about that. There we go. So the field of view that we're talking, where do we want to look? This is Rubin's LINCC camera. So this just gives a scale, sort of the full moon. How big is it that we're looking at the sky? Why does this matter? Why is Rubin good for this? Well, it's a really wide field of view, so we can see a lot of things at the same time. It's very faint. It's this large aperture telescope. It's at a great site in Chile. It's very well calibrated, so we can understand where it's pointing and what could be in there. This is especially important for our projects. We want to know where could the dots be, not just where have they been detected. And there's facilitated access. We heard about the Rubin Science Platform before. It's really quite amazing, and I will just say now and again that actually everything for Rubin Comet Catchers thus far has actually been done on the Rubin Science Platform. So for this actual data set that we're working with, we keep hearing about DP1, that's data preview 1. So this is with a smaller version of LINCC cam for commissioning. So this is just showing how big that area is compared to the commissioning camera. It is through the same telescope, on the same site, the same dome, same optical path. It's the same chips, etc. It's just 9 chips instead of a ton. So it's 1/22nd of the area on the sky. It was taken in late 2024. And it's a great quality data set, and it's a sort of a finite data set. I have to show this because we've probably already all seen it by now, but this sort of gives us some insights into what we're excited about. So this is from Rubin about the asteroids that were discovered in the commissioning validation, not with ComCam, but with the big camera. So I'm going to just let this play for a moment. And so each one of these is an asteroid that's discovered in there, and these are all cutouts. They're centered on specific areas in the sky so that you can see the asteroids moving. We're pretty stoked on the number of them being found. This is where they appear with that sort of projection of the footprint on the sky. And as they're more and more discovered, these numbers are increasing, the number of dots that are being shown in there. So that's just an absolutely tiny area on the sky that we're finding this huge number of asteroids. And this is just putting it in perspective for where Earth is and that tiny sliver on the sky. This is just one way of which we will repeatedly hear just how enormous the data set is that's coming for Rubin. And so this challenge is really too much everything. Like there's too many dots, there's too many images, there's too much data. And so that's great because this is one of the areas where citizen science really shines. So that's the LINCC camera, by the way. It's the largest camera ever built for astronomy. It's pretty big. I can't move this out of the way here. So it's an outreach and education opportunity first and foremost. So we can engage the public in a scientific quest effectively. That alone is reason enough to do these things. It's super exciting. But for practicality reasons, it is also great for these needle in the haystack problems and other overwhelming data sets. So we're, I guess, 300,000 per night is Jake's sort of the current estimate. We'll call it 500,000 detections per night. Comparing from the Active Asteroid Citizen Science program that I founded, that has a 35 million detections total since its 2012 launch. That's basically done in 3 months of Rubin at this rate. So even just in the commissioning data we have already, we're approaching all of what that cam has ever taken, and its observation is serendipitous. So the rough feasibility, if we had our Active Asteroids volunteers going at full bore, it would take about 150 days for them to look at one night of LINCC data. So we need to think about how we rescale this, even with citizen science being this great platform. There are many other benefits. There's less examination bias. I can't emphasize enough. I have looked at millions of thumbnails at this point in my life, and there are volunteers that are certainly better than I am at discovering tails and objects. It's really humbling and amazing. There are AI opportunities, which we'll circle back to in a moment too as well. So I mentioned Active Asteroids, the citizen science project called Active Asteroids before. So this is a proven concept already. This is something that I launched in 2021 with a team. And these are just some of the discoveries from that campaign. So the point of this one, as you could tell from the title, was mostly centered on asteroids with comet tails, known as active asteroids. But we did find a bunch of Jupiter family comets and other things along the way. The point here is that we have shown that it is possible to discover these objects that can normally be very difficult to discover with this type of endeavor. So just a brief crash course on what the actual workflow is for Rubin Comet Catchers. I know this is very opaque, so this will just be a little bit insight here. The way I go about doing this is to first consider what could be in the field. So this is through services such as Skybot or the Jet Propulsion Laboratories Objects of Field, or Single Frame Association, which is Rubin's way of doing things, of looking at what's in there. So I do this for every single exposure that is taken. And that's next up, I for each one of those that we want, we snag the detector from Rubin using their butler, and we make sure that the object is actually on the chip before we spend any more time on it. We do some other analyses before these stages as well, but that's too much for this talk. We reproject the images, so a common question is, well, isn't it confusing that the camera is rotating? It doesn't have to be. You just reproject it so that north is up and east is left, and that way they all look the same. So that's what, we make a cutout, something similar to that on the bottom left, and we do this CSI, like enhance command, and make it look as good as we can before we give it to volunteers to look at. So some technical details. It is a tech talk. All the work done is on the Rubin Science platform. I know people have a hard time believing this when I tell them that, but it actually has taken place inside the Rubin Science platform. The cutouts, the analysis, everything else is there. We have about 10,000 cutouts via my own cutout tool that I made. It does take about 5 seconds each. That can be done a little bit in parallel, but to be kind to other users of the butler, etc., that's basically what we pace it at right now. These subject sets, we heard about the subjects earlier. The subjects we upload about 500 kilobytes a piece. And then the unaltered fits cutouts that we make, so they're not rotated, those are about 600 kilobytes. And they have the variants and the science frame layers for those who want to know. For the flipbook workflow, so this is like an animation, we have multiple permutations. Like if we have 3 images, we show 1 and 2, 2 and 3, and 1, 2, and 3. We do have a cap on how many of those we do, but that's an important piece for this finite data set. For the volunteer training data, there effectively aren't really comets that we know of anyway in that DP1 data set. So we are using dark energy camera cutouts that look quite similar in terms of their contrast, enhancement, etc. And we're adding some negative training as well too, which is new for us. So this is what it looks like right now. If you were to go to the cometcatchers.net, it would redirect you to the Zooniverse page. And if you could classify, this is exactly what it is. So it's a very straightforward question of yes or no. Do you see a tail? Unlike before, we do have it animated. So the advantage of this is that folks can actually see, is the tail moving with that background or not? So the asteroid here is at the center of that crosshair, and the background is what is moving for all of our cutouts. So if it was a galaxy, like we see a galaxy over there, what might look like a tail in a static single frame, it's very clear, since it's moving away along with all the other stars, that is not a tail. So this is a big shift for us. We're pretty excited about that. And looking forward to how we incorporate that into the AI training, et cetera, too, for helping out volunteers. There's a talk button here for chatting on the forums, et cetera. We'll come back to that. That's, I think, an underrated feature in terms of discovery. There's a tutorial, there's a field guide to help volunteers along the way. So you're not just thrown into this without seeing anything when you first arrive at the page. There is some guidance. The plan for the live workflow is comparable to what we've done in the past. So this is also sort of tried and true for us. So we have this classification by the volunteers. We do analyze that data and we come up with candidates that way, which is awesome. But the talk forums for active asteroid synthesize project was the first one we came up with discoveries within a day of it launching. And so that's where people are sharing stuff and saying, hey, this looks interesting, and people talk about it. So both of those channels lead us to candidates, which our team will examine and vet. We carry out archival searches, maybe within Rubin or other data sets to see if we find anything else. And we follow up with telescopes and do science. Pictured here as coding, because that is how we write around here. Right, I couldn't, I'd be remiss not to mention 3i Atlas. I did ask Dolly to give me a pirate on a interstellar comet because some people are talking about it that way, and I just can't help myself. So the point of this slide is just it reiterates that in the live data set, when LCSD Cam is coming and I have data that I'm allowed to show from there, is it will be current and recent data, things that are happening and ongoing. And so for stuff like this, that would be very useful to have folks classify, et cetera. we will have those come front and center. And that leads us a little bit into this AI component too. So we want that current stuff to go in there for training AI. We have a very rudimentary AI assistant right now. So we mentioned before, it's a needle in a haystack problem. That means most of the time people click something, it's a no answer. And so this thing is trained mostly on no answers. And so it's pretty good at saying there's almost certainly not a comment in this image. And so the point of it is to filter out that chaff from volunteers. And so it really enhances the volunteer experience by doing that. It's not exactly designed to be turned on its head and say, find us comments. Maybe that will come in the future, but for now, this has led to 5 discoveries. There's a comical no picture icon on here, which is great since this is going on YouTube, and you could all be screenshotting right now, but they're not as top secret as maybe those images indicate. So lessons from the Active Astro Citizen Science Project. There are many, too many to put in this talk, but I just want to highlight one piece that I think is often underplayed. So we're talking about making discoveries. People usually think, oh, they're going to find a new comet. They're going to find something we didn't know was a comet. That's true, and those are exciting, but what we did not anticipate was the volume of discoveries about known active objects or other known comets, for example. And so at the time that this was made, we had a lot of people looking at a bunch of stuff, but we had a number of our publications and findings have been about known objects. This is just an example where there was this object, it already had a comet designation, it was known, but folks didn't know what type of active object it was really, and they did not know that it had been active more than once, and so it was recurrently active, which is diagnostic of the type of activity that's happening there. So we're excited about this as probably one of the big avenues for the DP1 data set that we have on Rubin Comet Catchers now. Discoveries about known objects. So some lessons learned along this process and some tips. Really starting early was very helpful. I learned this when I made the original Active Astros project. It took way too long though on that project to contact organizations. So I'm just gonna drive that home here. There are people at Rubin that are very excited about this, such as Claire and Eric. And so contacting them early is a really good idea. They have a lot of knowledge in there, and talk to other people at Zooniverse as well. They're excited to help, and you can really just streamline much better if you do that. If you are interested in becoming a NASA partner, we're a NASA partner, we're NASA funded. They have quite the juggernaut in terms of social media outreach and everything else. They also need time, and you probably shouldn't tell them 2 days before your project launches, which is what I did, but they know me, so it's okay, but don't do that. Getting feedback from friends and family and volunteer communities, and by the way, when I say friends, I don't mean ones that have PhDs in astrophysics. I mean people who've never looked at astronomy images before or something like that. It's super helpful. And related to that, like one thing that led to for us is adding this reticle, this little crosshair, so people know like what is this thing at the middle. Welcome translators. Like this was something that I was very reticent about before, but there's a whole new system at Zooniverse for handling this. Just because maybe even a country has English in their regular curriculum, it does not mean that it shouldn't be translated to another language. We are extremely thankful for our Chilean partners for being able to host this incredible telescope. So having the project be in multiple languages is super helpful. If you have a limited data set or a finite data set like we have things set, we have done these permutations, so these different combinations. That is a silver lining. If we were just live with the full Rubin data set right now, we would not have the opportunity to do this kind of testing to understand, is it really better to show volunteers 5 images and just skip ones when you only have 2? We wouldn't really be able to do that easily, and so now we're going to be better prepared. Higher retirement count, this is recommended directly by Chris Lintodd and Zooniverse. It's easier to have things retired later than it is to unretire them. And this gives people a chance to participate in your project. Like you don't want someone to go there and have there be nothing to do. And so this is fun. And volunteers are aware of this. You got to tell them what's going on. But it in our experience, better to let people actually try. Social media campaign first, full press later. This was a hard lesson to learn. Wish I had understood this sooner. It's very different than the first project that I launched. But I think that it's very effective, especially with all the publicity with Rubin recently. This has been a better strategy for us. So that just want to have a special acknowledgement to folks on the local launch team, especially Daniel, Devanshi, and Max, and Naomi, and Tobin, alphabetical by first name, and then Rubin and Claire and Chris have been super helpful, and Zooniverse, Chris Johnson and Laura both have been really helpful. Again, in summary, the project is live. You can go to cometcatchers.net now. It'll redirect you there. We've already had 1,000 volunteers, 1 million classifications, roughly, which is pretty great for such a just recently launching. it's DP1 now. It's going to have more data later. The preparations are ongoing now for that big data flow that's coming, and the AI work is ongoing. I have students that are working on that, for example. And so with that, I'm going to wrap up. I think we can open up the floor to questions for any of us at this point. Again, you can raise your hand in chat. You can type your question in chat. You can use the Slack, etc. Thanks very much.
There is one question from the chat. Meg asked about the website. I don't know if Claire want to classify. Sorry.
Yes, I was just going to respond, and I was going to say I have merged there's a bunch of content that I clearly did not get merged last time, so I really apologize that I didn't check that earlier, and check back later today once I figured out why my why everything's still sitting on a branch and not on the main site. So I'll fix that for you, Meg. I'm so
That does
sorry.
bring up a good point, though, which is that part of why I've been doing what I've been doing is to try to be a pioneer in this early effort and get a lot of all these things ironed out at this phase, and so it's going to be much smoother for everybody else who's trying later.
Yeah, and I will apologize on behalf of the EPO team in the sense that not as a shock to anyone, we were rather distracted by First Look for a few months, so our attention is now switching more heavily to CitSci, but there's a few things, like clearly this, which got lost in the chaos, exciting chaos of First Look.
Meg, let's see. There was one question in chat about data rights. Never mind. Meg, would you care to unmute? My favorite phrase.
You know, I'm never scared of that. I guess it's the more the canonical commenting question, which is dreaded. I just wanted if this is all great, I would say right now, I feel very overwhelmed by the DP1 documentation. And this being a separate site and not easy to find is really hard. And so I would ask or encourage, if possible, can we find ways of making this easily linkable from the DP1 documentation? A tutorial that walks through uploading DP1 data specifically, because I'm finding that there's things that are missing on the DP1 documentation, and like then having to go and find another site that does this stuff, having that kind of synergy would be really helpful. And maybe that's something the CST can help with, just because I feel like it's a fire hose of documentation and like click on this link and do this, and it's always kind of canonically been a problem for Rubin, I think. But right now, that's the feeling I have. And so if there's ways we can sort of make it easy to go or refer back to one to the other, I think that would be really helpful. Because that's kind of what I've been doing, is going through those things. And that's something I would want to do if I'm going to create a citizen science project. It's kind of go back and forth between DP1 and that. So I don't know if you have, it didn't seem like there's a specific example that runs from DP1 right now. Is that right?
Yeah. Well, hearing you loud and clear and completely agreeing with you. And yeah, there is the intention. So currently the CitSci effort has been developed a little bit in isolation of the rest of the CST tutorials, and we are in the process of merging those. So for future data releases and everything, we're not merging them entirely, but making sure that they all kind of come out together as a suite, and everything together is the plan. And so we're getting closer to that, and I will I'm taking note of your comment and thinking what we can do in this moment. But going
like
forward,
a link on the DP1 documentation would be a great start. And
totally,
some tutorial of DP, like a DP1 tutorial of like, here's how I take a cutout from the Butler in DP1 and move it over.
Yeah,
because I'm finding all the old data, like things are so different.
Totally.
So that would be super helpful. Or for solar system, we don't even have any image data, so it's our really first time even playing with the Butler for most of us.
100%, and we have some things there as well, and of course DP1 is a wonderful learning experience in many ways, and so yeah, hearing you loud and clear, and yeah, we're working on it.
Awesome. I'd Rachel, how you doing? Please go ahead.
Hi, thank you. So the microlensing team in TVS have been thinking about a citizen science component to classifying some of our targets. But given the nature of our science, rather than take data from the RSP in the form of images, we're actually working with the data streams coming out of the alert brokers. So those obviously include light curve data, somewhat bypassing the data rights issue because we're basing it on alert data rather than image data, which is helpful. But also we have a target and observation manager that is collating all of the stuff coming out of the brokers for microlensing and then trying to build a link from that to Zooniverse, which is a slightly different route. And I noticed in the first presentation, you were talking about things like data curation, keeping track of what's going to Zooniverse and the data flow that way. And then realized that, of course, our plan had bypassed all of that. So what do you suggest we do to move forward?
We should chat because yeah, we totally understand that the fact that so one of the things we've been aware of this is the fact that every citizen science project is going to be a little bit different and there's no one size fits all for anyone, and that's totally okay. And so we have also been thinking about the kind of direct from broker version of these projects, and so Zooniverse is kind of set up to ingest some of that data. And so one of the things that we have under development, but is not quite ready to kind of just send a link out, is to how to ingest kind of an alert packet, so it kind of can go that way. Also, some of the ingesting tabular data, that's for doing kind of light curve things. So if you have a light curve and then you can ingest it as a tabular file, and will display as a light curve on your citizen science project. So we have a lot of those things in mind. And so if you have a project specific really wanting to use those tools, let's talk and we can make sure that these things that we have sketched out are really optimized for exactly what you're thinking. Because the thing that we have been missing up until this moment is data and specific science projects that want to use some of these tools. So we're happy to refine them a little bit more closely. But yeah, that's very cool.
Cool. Okay, thank you.
All right, we have a question from Henry Shea in the chat. Hey, Henry. I was just asking about what resources are available, and Eric gave an answer there, but he was asking about your GPUs and disk space, etc. Claire, do you have an answer in addition to Eric's? I know Eric was saying we don't have anything that's sort of in addition to the RSP. I think that's fair. But this is a common question, and it would be great to have a place we could direct folks to answers.
Sorry, I'm just catching up on the question. And what Eric said. So yes, so essentially we provide a storage, as Eric mentioned, and we have the resources on the RSP, of course, that everybody has access to. Depending on project types, like if you have some sort of kind of active learning or something like that, there are some Zooniverse projects that are available, or Zooniverse resources that are available, but it's all very kind of specific to a project. So it's really hard to give a kind of bulk answer to what you're after. But if there's and again, sorry for giving the same answer I gave to Rachel, but if you want to chat and like kind of outline what you're thinking, what you think your use case would be, then we can kind of think about what resources are there and kind of how to utilize them. But it's a little bit hard to kind of give a blanket answer because there isn't kind of a one size fits all. But we have lots of storage for hosting things. That's for sure, as Eric has mentioned.
Yeah, I think I can give a blanket answer about the GPUs, that they are not there at the moment. We would like them to be there for us that are doing inference, etc. Meg, time for just like a very quick question. We've got to wrap it up by the hour. Go for it.
To ask about the 100 subject limit. I've never created a project where I used 100 to build and assess. I've gone through like 2,000, 3,000 by hand to figure out what my question should be. So I was just kind of wondering where did that 100 limit come from? And is that something that could be changed by default? Because to me, that seems like way too small, given the size of Rubin data set to build. And so just wondering where the logic for 100 came from to understand. Maybe it works for Rubin.
Yeah, so that limit is something we can totally change. So it's like the second you start thinking about your project and say, oh, I'm gonna need 1,000 to even start thinking about this, like that is a number that we can absolutely change. The intention of keeping it a small number is just so that if you somehow grabbed proprietary data that was not supposed to be made public not supposed to be presented to the public, that you can't accidentally, send a subject set of tens of thousands of objects that are still under embargo to the Zooniverse. But if you reach the kind of development of your project and say this isn't going to work for me, that is something that Eric can very, very quickly and very easily change.
Awesome, thanks so much. Yeah, this recurring theme of like just reach out is definitely a good starting point for some of these things, especially these early days. Okay, so that's all the time we have. I would like to say thanks again to our guest speakers and to everyone here for attending the LINCC Tech Talk series today. We will be taking a brief break in August and reconvene in September where we're going to hear about the LINCC Frameworks overview and updates by Jeremy Kubica. So we're going to hear about the sort of parent organization that's for these Tech Talks that host it. So in the interim, please join the LSST Discovery Alliance Slack, the hashtag LINCC Tech Talks channel if you can. Otherwise, there's a mailing list at LINCC, LINCC, at lists.lsst.org. And we can send announcements that way. There's, of course, the website. And there's LINCC Frameworks is going to be holding office hours every Thursday at 10 a.m., except when they conflict with this. And those details are also online. If you have an idea for a Tech Talk, we would love to hear from you. Please reach out to us via the LSSD DA Slack or email, which are both listed on that LINCC Tech Talk webpage there. And we will be posting this video on YouTube, hopefully in the next few days. And with that, thank you, everyone. Have a great rest of your day.